So this is what we have done in this session. This is the schedule, and in today's session we have finished with basic definitions, what and why we need statistics, different data types, qualitative, quantitative, discrete, and continuous. So all these basic things which are required to start the course, we have covered in today's session. Now we'll just shift on Excel and we'll try to complete the graphical representation of data for qualitative data and quantitative data. So I request all of you to start your Excel on your machine, and then I'll tell you to how to install the data analysis tab. It is a plugin actually, how to install that, and then we'll start with a few of the data representations also. So, okay, so now first thing, the most important thing, just go to data section, data tab. Just go to data tab and see if you have this data analysis option available. Data analysis tools for financial and scientific data analysis. Is this option available to you?
No.
Okay, so I'll tell you I'll tell you how to add this plugin. So you have to go to the file section and options. In file section, you have to go to options. Now, based on what version of MS Excel you are using, the location may be some different location. That options location may be something different, but you have to go for options, Excel options. You will get this kind of window, Excel options. Have you got this?
Yes.
Yes, all of you? Yes, Amir?
Just a moment. Yes.
Okay, Divya, Priya?
Yes.
Okay, fine. Nandan, Vandana?
Yes.
Okay. Now, once you have this option, there is one option called as add-ins. Click on add-ins. And by default, in disabled application add-ins, you will find first option as analysis tool pack. Because I have installed, it is in active applications. In your case, it will be in disabled or inactive applications. Just look for inactive application add-ins. You will find first option as analysis tool pack. Just click on that and click on go. Click on analysis tool pack and then click on go. Then you will get this kind of window, add-ins. Just select the first option, analysis tool pack. No need to select other three. Just select the first option, analysis tool pack, and then click on OK. I'll not click because I have already installed. If you click on OK, what you will get is this option in data section, data analysis. Have you got this option? Yes, have you got this option, data analysis?
Yes.
Okay, so once you click on data analysis option, you'll get all the possible methods which we can do in Excel using data analysis tab. So out of all these options, I'll tell you what we are going to cover in this course. We are going to cover ANOVA single factor, ANOVA two factor with replication in last few sessions. Then correlation covariance we are going to cover in session number 4 and 5. Descriptive statistics we are going to cover in tomorrow's session. Then histogram we are going to cover in today's session. Then regression we are going to consider in session number 4. T-test, paired sample, T-test, two sample with equal variance, and T-test, two sample with unequal variance we are going to cover in session number 6. And Z-test we are going to cover in session number 7. So out of all these options, almost 90% options we are going to cover in this course. And this is what max you can do using Excel. This is the kind of analysis you can do using Excel. Fine. So the data sets are with you and data analysis tab is available to you. So for first few data sets, you don't need data analysis tab. We are just trying to graphically represent this data. So what I'll do is I'll share a few documents also on WhatsApp group. Just download those documents and then we'll start with data representation. Okay. So you must have noticed this data set is from the qualitative document. So we have all these observations. We have almost 50 observations. So how to know that? If you just select all the values in the Excel, you will get this summary at the bottom ribbon. This is the bottom ribbon. In bottom ribbon, you can get the summary count is 50. So we have 50 observations. Likewise, you can get multiple aggregate functions and other functions in the bottom ribbon. So just right click on the bottom ribbon, and then you can select what else you want. Like you want to show minimum, maximum, sum, and other things. So if you can see, I have ticked for average, count, minimum, maximum, and sum, all options. I have ticked for average, count, numerical count, minimum, maximum, and sum, all the options to be displayed in the bottom ribbon. But now Excel has understood that this data is qualitative data and we cannot calculate average, minimum, maximum for qualitative data. Sum, addition is not possible. So it has just showed me the count value, which is 50, which is getting displayed here. And others are not getting displayed because this is qualitative data. Now we have to create a frequency distribution table for this qualitative data so that we can draw the bar graph and pie charts. So how to go ahead with frequency distribution? So I need to count how many Coke Classic observations are there. So I want to count the frequency of Coke Classic. So either I can go by manual method, 1, 2, 3 kind of, I can start counting the Coke Classic observations, or I can go for a function. So in Excel, if you want a function, if you want to use a function, just type equal to sign, and then you can type any function which is available in Excel. So you have a function called as COUNTIF. In Excel. So type COUNTIF into bracket range. That means the data range. So my data range is all these values. So I'll select all the values as my data range, comma, criteria. That means you want to count for which criteria, for what condition. So what is my condition? I want to count all Coke Classic observations. So my criteria is D3, Coke Classic. Either I can write D3 or I can write into double quotes and Coke Classic. Both ways it is possible. Coke Classic ending double quotes. Or directly I can write D3. So 19. That means Coke Classic is present for 19 times. Instead of Coke Classic.
So just one doubt.
Yeah.
So how you got this classes? Like, did you use any function or manually you just put there?
No, manually I have put there. For qualitative, you don't have any option in Excel. For quantitative, I'll show you on further like histogram and everything, how to create classes. But for qualitative,
So
you have
remove
to type
duplicates we can use?
Yes, you can use that. You can use that.
Okay.
Yes.
Thank you.
Okay. So COUNTIF and then the criteria is Coke Classic. Otherwise, you can directly give the D3. You'll get the same output, 19. Now, I want to do the same thing for remaining cells. So if I just copy and if I paste it here, what is happening is if you look at the first formula, the range is B2 to B51. B2 to B51. When I copy and paste in the next cell, because I am advancing to next cell, automatically it will advance the cells in the formula part also. It is going to B3 to B52. So I want to keep B2 to B51 as the fixed part, constant. I don't want to change that because my data range is not going to change. So part of the formula which you don't want to change, you have to put $sign there. You have to put $sign there. So I'll write $B, $2 and $B, $51. That means don't change B and 2. That is the starting cell of my data. And don't change B and 51, which is the ending cell of my data. Keep it fixed. Even if I copy this formula and paste it somewhere else, this part of the formula will remain constant. Okay. Now I'll just copy this and then I'll paste it in the remaining cells. and what I'm getting is the frequency distribution table automatically. You can see automatically D3 has become D4, D4 has become D5, D6 and D7, but the first part has remained constant. And that is how you can use the autofill option in Excel, and this becomes my frequency distribution table. Yes, any doubts? Have you done the same thing on your Excel?
Yes.
Okay, now it is very easy how to draw bar graph and pie chart. You must be aware of all these things, but just at part of the process and course, I'll just show you. So I'll go to, I'll just select the data, all the headings and all the frequencies. Go to insert chart option, simple chart, and you'll get the bar graph. Simple thing. Similarly, if you want to draw a pie chart, again select the data with labels, go to insert, pie chart, simple pie chart, and you will get the pie chart. So these are very simple options. You must be aware of this, how to draw bar graph and how to draw pie charts. So this is how you can deal with qualitative data. So what max you can do with qualitative data is, you can go for a frequency distribution table, you can go for a bar graph, or you can go for a pie chart. That is what max you can do with qualitative data. Is it clear? Okay, so I will start with the remaining part of today's session. So now I am dealing with quantitative data. As you can see, every number is significant. So I need to create groups out of this data. I need to create a group data out of this. Like I am to create class intervals like 10 to 15, 15 to 20, something like that. Now how I can decide what class intervals I should have? Once you select the data, you will get minimum and maximum values, 12 and 33. That means you should have class intervals which will cover your minimum value and which will cover your maximum value. So maybe I'll go for class intervals like 10, 15, 20, 25, 30 and 35. So in Excel, I call them as beans. In Excel, I call them as beans. So you have to give all your bean lengths. So 10, 15, 20, 25, 30, 35. These becomes my bin lengths. These becomes my bin lengths. Now next step, how to create class intervals and then how to create histogram out of it. So I'll cover both the things so that you can implement the same thing for these two problems as practice. Okay, so go to data, select data analysis and select histogram option. Select the histogram option, click on OK. Once you select the histogram option, it will ask for input range and bin range. So input range, yes, we have this input range, including label, select everything, input range. And bin range, yes, we have defined the bin range. So this is my bin range, including label. Labels, I'll take on this option because my first row in both the input range and bin range, my first row contains labels. So I'll click on this. If you are not selecting this cell, then don't click on labels. Output range, what happened? I'll just go back. Yeah, output range, suppose I want to start my output from say this location, and what I want is only chart output because I don't want anything else. I just want a histogram, so chart output. So after all this, just click on OK, and what you have got is histogram and the bin range. And yes, so if you look at this output, then this bin talks about all the values which are less than 10. Then this bin is about 10 to 15. So you can say the lower limit is 10 and the upper limit is 15. Then this is group 15 to 20. This is 20 to 25. This is 25 to 30 and this is 30 to 35. So you get this grouped data because of this option automatically ready-made. So you can just create a group data, interval data out of this list of data values. Now look at the histogram. We say that histogram is continuous. We say histogram is continuous. So we want to make this graph continuous first of all. So just click on any of the bars. Just click on any of the bars. Right click, format data series. right click and format data series. Once you'll right click and format data series, you'll get one option called as gap width. You'll get option as gap width. Just make it 0. Gap width, make it 0%. And you'll get the histogram. So this is the histogram for this table. So this normal quantitative data, we have converted that data into a group data, and we have drawn the histogram for that data also. So this histogram is showing us the distribution of data. This histogram is showing us the distribution of data, how data is distributed, between the minimum value and the maximum value. So you can see a large amount of data points are between the minimum value, which is I guess 10, and the value which is close to 2025. So we have a large number of observations which are between 10 to 25, and then we have very less observations which are between 25 to 35. And because of that, we can see the distribution is having a slope towards the right hand side. This distribution is having a slope towards the right hand side. So if I draw the distribution of data in a curve format, I may get a curve something like this. So for my curve, I am having slope on the right hand side. So in case of distribution of data, we can have multiple types of distributions. Either we can have a symmetrical distribution, or we can have non-symmetrical distribution. So when I say symmetrical distribution, symmetrical means when you have a kind of bell-shaped curve. When you have a kind of bell-shaped curve, then that is a symmetrical distribution. That means you have same kind of curve on both sides of the middle line. Now this middle line is represented by mean generally. This middle line is represented by mean. So we say that distribution is symmetrical around the mean. Distribution is symmetrical around the mean. Now in this case, what is the mean value of this data set? If you look at average value, it is 19.25. It is 19.25. This is the average value. This is the mean value for this data set. Now, if this is the mean value for this data set, where I can plot 19.25, where I can plot 19.25, somewhere here. So this becomes my mean. This point becomes my mean. So you can see my data is not distributed evenly around the mean. The number of observations on the left hand side are more compared to number of observations on the right hand side, but they are in more spread format. So we'll come to this when we'll discuss measures of shape. What I'm talking about is the concept of skewness, that we can have either right skewed data or left skewed data. And in that case, we say that it is non-symmetrical distribution. So based on histogram, you can do multiple types of analysis. And what is the ideal distribution is the bell-shaped curve. When you have a symmetrical distribution around the mean, we call it as we have a bell-shaped curve distribution or normal distribution. What Nandan said in yesterday's session, that word is called as normal distribution. Normal distribution means evenly distributed around the mean. So we'll discuss that concept in more details once we'll complete standard deviation and variance and other concepts. So this is a kind of benefit of having distribution in front of you. You can have multiple types of analysis based on distribution of data. Fine. So now we'll go ahead and now this data set, this is a group data. So this is my first group of 10 to 20 with frequency 4. And this is my second group with 20 to 30 with frequency 7 and so on. So in this case, this is my lower limit, this is my upper limit, and this is my frequency. So these are my 3 columns. So what we'll discuss right now is the concept of cumulative frequency. Now when we say cumulative frequency, there are 2 types of cumulative frequencies. First is less than cumulative frequency, and second is greater than cumulative frequency. So we have 2 types of cumulative frequencies: less than type of cumulative frequency and greater than type of cumulative frequency. Now first I'll tell you how to calculate, and then I'll tell you the meaning. So less than cumulative, the first value will remain as it is, that means 4. For the second value, it is the current frequency plus the previous total. So total becomes 11. So 4 plus 7, 11, 11 plus 8, it is 19. So now I have to repeat this formula for remaining cells. and that will give me the cumulative frequency of less than type. Similarly, greater than type of cumulative frequency, the same process I'll start from the bottom of the table. So my first value will be as it is in the frequency. Then the second value will be the current frequency plus the previous total, 3. And similarly, I have to copy paste this formula for remaining cells. So if you can look at the total, it remains same, 50 in both less than and greater than cumulative frequency, because total of f is 50. Fine. Now, what is the meaning of less than cumulative frequency? What is the use of less than cumulative frequency? Suppose if I ask you a question that how many observations I have below 40. How many observations I have below 40. So in that case, if I want to count number of observations which are below 40, I have to start counting all the observations from 10 to 20 class interval, 20 to 30, and then 30 to 40. That means 4 plus 7 plus 8. That becomes 90. So when I want to check how many observations are under or lesser than the upper limit of any class interval, I have to go for the less than cumulative frequency. Suppose if I ask you how many observations I have below 60. So when my question is about how many observations below the upper limit of the class, go for the less than cumulative frequency. Simple. Number of observations are 40, which are less than 60. Now this concept is very important, less than cumulative frequency, because it is used in calculation of median of group data. So when we'll discuss mean, median and mode, I'll explain you what is the use of less than cumulative frequency in calculation of median also. Similarly, for greater than cumulative frequency, if I ask you how many observations are above 30, how many observations are above 30? If I want to count a number of observations above 30, then I have to count all the observations above the class interval of 30 to 40, that is 8 plus 12 plus 11 plus 5 plus 2 plus 1, and that comes as 39. So whenever my question is how many observations above the lower limit, go for the greater than cumulative frequency. So it is generally said, the two statements which are very important, when the question is about how many observations are less than upper limit of any class interval, then go for less than cumulative frequency. And when I am asking about how many observations are greater than lower limit of the class interval, then go for greater than cumulative frequency. So these two statements are very important. So have you understood cumulative frequency? It's a simple concept. As the name suggests, it's a cumulative effect. So I'm adding all the frequencies one by one of all the class intervals and creating that cumulative effect. So that is the meaning of cumulative frequency. Now, based on this cumulative frequency concept, we have a graphical representation of cumulative frequency. So we have seen the graphical representation of group data in terms of histogram and then in terms of bar graph and pie chart for qualitative data. But then you have a different type of data representation only for cumulative frequency, and that concept is called as Ogive curve. That concept is called as Ogive curve. Ogive curve. So in case of Ogive curve, as we have two types of cumulative frequencies, we also have two types of Ogive curve. One is less than type of Ogive curve and second is greater than type of Ogive curve. So now we'll see how to draw these Ogive curves in Excel. Yes, are you with me? Have you understood everything? Can we go ahead? Yes, okay. So what I'll do is I'll just create two different tables so that it will be easy for me to draw the Ogive curve. So I'll copy this less than cumulative frequency as a separate column, maybe here itself. So I have to copy them as values only because there is a formula. Okay, so this is my less than cumulative frequency and this is my greater than cumulative frequency values. Now, as I have told you that whenever I talk about less than cumulative frequency, now these less than cumulative frequencies are linked with upper limit of the class, correct? Because we have discussed this example. If I want to count how many observations are below upper limit of the class, we go for less than cumulative frequency. So less than cumulative frequencies are always linked with upper limit of the class, and the greater than cumulative frequencies are always linked with lower limit of the class. So I'll just group together all these things so that fine. So now what I have to do is I have to just draw the graph for these values. And what kind of graph I have to draw? Ogive curves are line chart. Ogive curves are line charts. So that's why these are called as curves. So these Ogive curves are types of line chart. So I have to draw a line chart for this table and I have to draw a line chart for second table. So I'll select all the values of both the columns for less than cumulative frequency, go to insert, and then I'll go for a line chart and simple line chart. Sorry, just a minute. Okay. So just select all the less than cumulative frequencies, simple line chart, and you'll get a less than cumulative type of line chart. I'll keep it here. Now in this chart, if you look at x-axis, it is showing default values as 1, 2, 3, 4, 5, which I want to replace with the upper limit values, which is in this column. So what I have to do is just select the x-axis, right click, and click on select data. Now the default values are 1, 2, 3, 4, 5, which you can see here. So you have to click on edit, and then you have to select the labels. So I'll select whole column, because these are my labels on x-axis, and once I select, you can see x-axis has changed. Now it is showing all the values between 20 to 90. I'll just click on OK, and now this is my line chart, or I can say this is my less than type of Ogive curve. Okay. Now similarly, I can draw the greater than type of Ogive curve. So I'll try to draw greater than type of Ogive curve also. So what I have to do is again select all the values in greater than cumulative frequency, go to line chart, simple line chart. It will be exactly in opposite direction, has to be, because the process is also exactly opposite. And now in this case, I have to change my x-axis, select the x-axis, select data, and click on edit, and select all the values of lower limits of the class intervals, and click on OK. So this is my less than type of cumulative frequency, and this is my greater than type of cumulative frequency. Less than type of Ogive curve and greater than type of Ogive curve. So this is how you can draw the Ogive curve in Excel. Now what is the basic use of these Ogive curves? If anybody can guess, what is the use of Ogive curve? Yes, anyone? Okay. So the basic use of Ogive curve is, now we are slightly moving towards the prediction model. These Ogive curves can be used to predict the values. For example, I have all the values which are at 20, 30, 40, 50, 60, 70, 80, and 90 in my table. But what if I want to count how many observations I have below 45, for example? How many observations I have below 45? That value is not available in the table, but I can try to predict. It may not be 100% correct. I can try to predict how many observations are below 45 using this graph. So if this is 40 and if this is 50, I can draw a line at 45 approximately. So it is coming here. So what is this point at 45? Is approximately something here. So that means I have approximately 25 to 26 observations which are below 45. So I'm trying to predict something. Now it is not the actual use, and this is not the best method to predict something, but this is how you can use Ogive curve. There are multiple other use cases also. We'll come to that one by one. But this is the basic use of Ogive curve. You can try to predict some values which are not available with you in the data set. Presentations. So we'll start with this presentation. We'll try to complete this in today's session, data representation. So we have gone for this basic data representation, which is frequency distribution table. Then for qualitative, we have seen bar graph and pie charts. For quantitative, we have seen the histograms and Ogive charts, and we'll see the remaining part in this presentation. So the same example we have used, and how to create the frequency distribution table. Now we are aware of this, how to use this in Excel. So I'll skip this slide. Relative and percent frequency, why we need this? Because if you want to calculate the angles for the pie chart, we draw a pie chart in a circle, and one circle has 360 degrees of angles. So if you want to draw the angles for a specific portion of any soft drink, then you have to calculate the relative frequency and percent frequency first. So what is relative frequency? It is frequency of that class divided by total. So the frequency of the Coke Classic is 19, divided by total is 50. So 19 upon 50 will be the relative frequency of Coke Classic. 8 upon 50 will be the relative frequency of Diet Coke. 5 upon 50 will be the relative frequency of Dr. Pepper, and so on. So relative frequency of a class is the fraction or proportion of items belonging to the class. So what is the fraction of Coke Classic to the total number of items? What is the fraction of Coke Classic to the total number of items? The fraction is 0.38. Likewise, the fraction of Diet Coke to the total number of observations is 0.16, and so on. So if I add all the relative frequencies, the addition has to be 1. Because if I divide total by total, the value will come as 1. And if I multiply the relative frequencies by 100, what I get is percent frequency. So we have 38% of observations with the name Coke Classic. There are 16% observations for Diet Coke. There are 10% observations for Dr. Pepper, and so on. So total of all the percent frequency has to be 100. Then how to draw the bar graph? We are aware of this. If you have a data set with you, how to draw the bar graph, and you can do this in Excel now. Then how to draw the pie chart? We know how to draw the pie chart in Excel, but if you want to calculate the angles, then first you have to calculate the relative frequency for each class, for each level, and then you have to multiply that relative frequency by 360, because one circle has 360 angles. So 0.38 into 360 will give the angle for Coke Classic. So consider this as a baseline. Calculate the angle 0.38 into 360 and draw that angle here, and that will be the portion for Coke Classic. Then consider this as a baseline for Pepsi. And then calculate 0.26 Pepsi, relative frequency is 0.26 into 360, whatever is the angle, and draw that angle here, and so on. Continue this process, you will get a pie chart for the given data set. Next is if you want to convert the quantitative data into class intervals, what is important is to define number of classes, to define appropriate length or the width of the class, then the upper limit of the class and the lower limit of the class, and the class midpoints. Yes, so this is the way in which you can draw the dot plot. Now these dot plots can give you how many observations you have. So it's a kind of representation of frequency distribution table only, but with frequencies of individual data points. Dot plots will give you frequencies of individual data points. But these dot plots are useful when you have a small data set, up to 50, 40, 50, 60, 100 values. But if you have 3,000, 5,000, 50,000 values, then dot plots are not a preferable option. So this is one of the methods to represent data if you have a small data set. Then the next method is histogram, which we have discussed already in details, how to draw histogram out of the table. So we know that. Next is cumulative frequency. We have done this also. We know how to calculate less than cumulative and greater than cumulative frequency out of the data set. Then how to represent the cumulative frequencies in graphical method is using Ogive curve. So we have two types of Ogive curves, less than Ogive curve and greater than Ogive curve. So that also we have covered in Excel. Next type of data representation is stem and leaf. Now what do you mean by stem and leaf is we generally have one common stem and then we have multiple leaf values. So that is the same structure in stem and leaf display also. So we consider the first row only. If I consider only first row, all the values 112, 72, 69, 97 and 107, I'll just write down all those values in the first row in a ascending order. So from 69 to 112, 69, 72, 97, 107 and 112. You can see there is a blank in between 72 and 97 because we don't have any value in the 80s. So I write down all the values and then we have to decide what is the size of a leaf and what is the size of a stem. So I'll consider all the unit places is my size of leaf or leaf values. So what I'll do is I'll draw a line between my unit places and remaining part of my numbers. So the left hand side becomes my stem and the right hand side becomes my leaf value. So I have a leaf of 9 for stem of 6. I have a leaf of 2 for a stem of 7 and so on. So there is no leaf for stem of 8. That because of that it is blank. So this becomes a representation of my stem and leaf of first row only. So I have to repeat this process for second row, third row and remaining data set. So in next row, I have first value as 73. So already I have a stem of 7. So what I'll do is I'll add a leaf of 3. After 2, I'll just write down 3. That becomes a leaf of 3 for stem of 7. So I can easily recreate my original data if I know this is my stem and leaf. So the value has to be 69, 72, and if there is a 3, then it has to be 73 and so on. So if I repeat this process for all the numbers, what I get is, if I repeat this process for all the numbers, what I get is this. What I get is this. So the values are like 69, 68, 72, 73, 76, 73, 76, 75, and so on. In case of double digit, this is 107 is the first value, 104 is the second value, and so on. Now, if you look at all the leaf values, they are not in sorted manner. So the next step is just to sort the leaf section, and you'll get this. If you sort the leaf section, you'll get this stem and leaf display. So this is the stem and leaf display output, and from this you can come to know that at what stem you have the maximum number of observations. So maximum repetition is in the 90s. Then we have repetition maximum, next maximum repetition in the values of hundreds, then 80s, then 110, and so on. We have least number of observations at 140 and at 60. So this is a stem and leaf display. Again, just like dot plots, stem and leaf display is useful in case of small data sets up to 40, 50 or 100 values maximum. What is the use of this stem and leaf? If you look at histogram, actually if you rotate anti-clockwise, this stem and leaf, if you rotate it anti-clockwise, what you get is histogram. So the only difference is in case of histogram, you don't get all the internal details, which are the actual values. You just get the top value that we have these many observations in 90s. But in stem and leaf, you can get the internal values also. So if you rotate this stem and leaf anti-clockwise, what you get is histogram. Fine. So this is another method to represent data, stem and leaf. The next is CT, that is cross-tabulation. Now we have discussed tabular and graphical methods used to summarize the data for one variable at a time. So whatever we have discussed till now, all the data sets, we are talking about only one variable. Often a manager or decision maker requires tabular and graphical methods that will assist in the understanding of the relationship between two variables or maybe more than two variables. So at least two variables. So if we have to represent two variables at a time, then there is a tabular method and there is a graphical method for that. So to represent the association or the relationship between two variables, we have cross-tabulation, which is a tabular method, and scatter diagram, which is a graphical method. So first we'll look at the cross-tabulation method. Suppose I have this data, cross-tabulation. Again, I guess this PDF also has been shared with you yesterday about cross-tabulation and scatter diagram. So if I have this kind of data, suppose if I go to restaurant number 1, and then I'm just checking what is the quality rating for that restaurant after having food. Suppose if I think that restaurant is good and meal price, average meal price is 18. Then I visit second restaurant. After having food, I decide that, okay, quality is very good and the average meal price is 22. So likewise, I'm visiting maybe 300 restaurants. If I'm visiting 300 different restaurants, I am taking two data points. I am considering two variables for each restaurant. One is quality rating and second is meal price. So quality rating is my first variable and meal price is my second variable, which I am noting down as data points for each restaurant out of 300 restaurants. Now in this case, quality rating is a qualitative variable. Is a qualitative variable. So I can say these are ordinal variables: good, very good, excellent. And meal price is a quantitative variable. And because it is price currency, it has to be ratio type of variable. So I have one ordinal variable and I have one ratio type of variable. Now I have to do analysis for these 300 restaurants based on the data which is collected. So I can represent the same data in a tabular format. I can represent same data in tabular format. Because quality rating is ordinal variable, I can represent them into labels: good, very good, and excellent. I cannot group them together. And meal price, it is currency, so I can create class intervals out of it because it is a quantitative variable. So in rows we have quality rating and in columns we have meal price. Now what is the meaning of 42? Yes, anyone? What is the meaning of this 42? Yes, anyone? What is the meaning of 42?
The dishes which are between prices 10 to 19, they have been got good rating 42 times.
Yes. So out of 300 restaurants, the total restaurants are 300. Out of 300 restaurants, there are 42 restaurants with good rating and serving food in between 10 to $19. The average meal price is between 10 to $19. There are there are only two restaurants out of 200 with a good rating and serving food with the average meal price between $30 to $39 and so on. So every value is associated with two variables, one in the rows and one in the columns, is associated with two values. So generally we call all these values as joint values, and all these values as marginal values, Now what is the meaning of this 76? What is the meaning of this 76? Yes, anyone? So irrespective of quality rating, when I say 76 is a marginal value, irrespective of quality rating, there are 76 restaurants out of 300 who are serving food between $30 to $39. Who are serving food with the average meal cost as $30 to $39. So this 76 is only associated with the column heading. Similarly, this 84 is only associated with the row heading. There are 84 restaurants out of 300 which are having good quality rating. So likewise, I can represent the two variables for 300 restaurants in a tabular method, and this method is called as cross-tabulation. We are not going to go into more details of cross-tabulation. If you go to SPSS, there are multiple methods using which you can do analysis on cross-tabulation. Now, if the total number of restaurants are 300, and if I divide all the values by 300, then what I get is the probability value. If I divide all the values by 300, because the total is 300, so I'll get 1 here. And what I get here is the probability value. So there are 14% restaurants. With good quality rating and serving food between $10 to $19 and so on. So these are my joint probabilities and these are my marginal probabilities. Okay. So this is just for information how you can calculate probabilities, though probability is not part of this course. So we'll now go to the next slide. So this is how you can create cross-tabulations and you can do the analysis based on cross-tabulations. Next is the graphical representation of two variables. So for graphical representation of two variables, we use scatter diagrams or scatter plots. So scatter diagram is a graphical representation of relationship between two quantitative variables, and we can add a trend line in Excel. I'll show you how to do that. We can add a trend line which provides an approximation of the relationship, what type of relationship we have, whether we have a positive relationship or a negative relationship. So suppose we have this data set. Now the same data set is there in Excel. So I'll shift on Excel. So the same data set is here. We have data about 10 weeks with number of commercials which I'm releasing in media and what amount of sales I'm getting for my products. So in week number 1, I'm releasing only 2 commercials in the media, whereas there are 50 products which are getting sold. Then in second week, I'm releasing 5 commercials and my product sell has been increased to 57. Likewise, I have data for 10 weeks. Now I want to understand the relationship between commercials and sales. If I float n number of commercials, what can I expect as my sales? So just select these 2 columns with all the data values and go to scatter diagram. Select the simple scatter diagram. So this is your simple scatter diagram from this data. Now if you look at this scatter diagram, we don't have any values on the y-axis till 30. We don't have any values on y-axis till 30. So what we can do is just select on y-axis, right click and format axis. If you click on format axis, it will ask for the minimum maximum value. Right now it is by default 0 and maximum is 70. you can change that and you can make it 30. So auto will become reset and value is 30. Even you can go for 35 also. So I'll make it 35. So you can see y-axis is starting from 35 now. So this is how you can plot your x and y values. So for 2, I am plotting 50. For 5, I am plotting at 57. 1 against 41 and so on. If you go to any one data point, you can see data point 2, 250. Then this is data point 3, 354. So this is a data point 354 and so on. Now from all the data points and looking at the scatter diagram, you can see there is a upward trend. There is an upward trend. That means if I increase number of commercials, my product sell is going to increase or increasing. Right now I am seeing upward trend. This is called as positive relationship. When I increase X, if Y is also increasing, that means there is a positive relationship. With increase in X, if Y is decreasing, that means downward trend, then I call it as a negative relationship. So we'll cover in more details about correlation in case of correlation in the session number 4 and 5. So right now this is scatter diagram output, and now if you select any one data point in the scatter diagram, by default it will select all the data points. Click on any one data point, right click, and then you'll find one option called as add trend line. Add a trend line. So click on add trend line. We'll keep it to linear because non-linear relationships is not part of this course. So we'll keep it linear by default. Maximum what you can do is you can display the equation on the chart and the R-square value. Right now you don't know anything about R-square, but still if you want to, you can go for equation and R-square value. So this is your equation of line and the R-square value. So this is the line which is representing the relationship between X and Y, which is trying to represent the relationship between X and Y. And from this line, I can say it is upward trend, and we have a positive relationship between number of commercials and the product sales. Now, what is the use of this equation? Y equal to 4.95x plus 36.50. What is the use of this equation? Again, we'll try to predict something which is not available with us. I know that if I release 2 commercials, then what sales I get. I know what if I release 5 commercials, what sales I get. So I want to know if I release 10 commercials, what kind of product sell I can expect. So what I can do is, this equation is representing this line. All of us are aware of equation of line. It is in form of y equal to mx plus b, where m is the coefficient of x, we call it as slope with x-axis, and b is the constant, which is the intercept on the y-axis. But this is the equation of line, y equal to mx plus b. So it is similar. What we have got is y equal to 4.95x plus 36.15. So if I want to calculate my cells, which is my y, for x equal to 10, I have to just put x equal to 10 in this equation and I'll get a value of y. If I put x equal to 10 in this equation, I'll get some value for y. But that is my expected value of y. If I put x equal to 10, whatever y I'll get, that is my expected y. In reality, what actual cells will happen, that number may be different. It will be very close to this expected y, but that number may be different. And in statistics, we do all kind of analysis just to understand this, that how each data point is deviating from its expected value. How each data point is actually deviating from its expected value. So what is the difference between the expected value and the actual value? Again, the same thing which I have tried to explain in yesterday's session. Whatever analysis we do is, the basic concept is to understand the deviation of all the data points from the expected values and to minimize that deviation, minimize that error. Fine. So even if in this case, if you look at all the values which are available with us, if you say value of x is equal to 1, for x is equal to 1, what is the expected value of y? If I put x is equal to 1 in this equation, what is the expected value of y? It is 36.15 plus 4.95. X is 1, then it will become somewhere around 41 point something. It is not exactly 41, it is 41 point something, 41.5 or something. That means the expected value is something else, but it is very close to the actual value. That means deviation is very less. So you can see this is my deviation. This line represents expected value. This line is of expected values. This line is of expected value. So there is small deviation of each data point from the expected value. So if I consider this data point, this is a deviation value. This is a deviation value. This is a deviation value. This is second deviation. This is deviation. This is deviation. So we are talking about all the differences of the actual data points from the expected data points. So we'll go into more detailed analysis of these deviations, what we call them as residues in the case of correlation and regression. But this is the use of scatter diagram. It will tell you, it will show you what is the overall trend of the data set and what is the dispersion in my data set, how my data values are deviating from my expectation line. Okay, fine. So this is all about scatter diagram, which we have finished. So I'll go back to the presentation. Yes. So for this data, we'll get this kind of scatter diagram, and then we can do multiple types of different analysis based on scatter diagram also. I have just given one example of how can I try to predict the value for x, which is not available with me in my table, using this equation of straight line, which is also called as a regression line. Let me tell you, this line is also called as, this trend line in Excel is also called as a regression line. And we have multiple types of regressions. We can have a linear regression, we can have non-linear regression, we can have single regression, multiple regressions. So we'll try to cover a few of the regression types also in this course. So relationships based on the scatter plot. So this is a case of positive relationship. This is a case of positive relationship. This is a case of negative relationship. And this is a case of no relationship.